To answer this question, you have to figure out how many grams of iron 2 chloride are going to be in every 100 grams of this water. Well, if it's a saturated solution, we go to our table and we find that at 30 degrees Celsius, 70, and it doesn't say 0.0, it should, I need to correct that, 70 grams of iron chloride, iron 2 chloride, is what we will have per 100 grams of water. Okay, so we need to know how many moles this is and what portion of a kilogram that is. Two different problems, and then you put it together in molality equals moles of solute over kilograms of solvent. Terrible, terrible writing. Okay, so once we've figured out how many moles we're talking about and what portion of a kilogram we're talking about, we're ready to go ahead and plug those in. So we've got our 0.552268245 moles of our iron 2 chloride in 0.1 kilograms of water, which gives us a 5.52268 molal, etc., 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 molal solution. Since we really only had one sig fig here, this would be a 6 molal solution of iron 2 chloride. Okay, clear? So question number 2 asks, the 2.5 molal iron 2 bromide solution at 50 degrees Celsius, saturated, unsaturated, or supersaturated? Now the supersaturated part is kind of a trick question. You wouldn't know that. You wouldn't know that. If it's got more solute than it can hold at that temperature, it's definitely saturated. The only way to tell if it's supersaturated is visually. If it has more solute than it can hold, but you're not seeing any precipitate or any crystals on the bottom, then it is just saturated. If you're seeing nothing like that, if it's all clear and there's no precipitate, no undissolved material in it, then it's supersaturated. So that's a distinction. You should watch the tutorial. What's the first thing we have to do here? Well, we need to figure out how many grams of iron 2 bromide are in this 2.5 molal solution per 1 kilogram. So we have molality equal to moles of solute divided by kilograms of solvent, and we know this, and we can figure this out. We're going to assume this is 1. We're going to assume that that is 1. It's easy to do. So if we're assuming that this is 1 kilogram, how many moles is that? 2.5. So a 2 molal solution would be 2.5 moles of your solute in 1 kilogram of your solvent. There are probably a couple other ways to figure that out, but that's the easy one that occurs to me. So we take that 2.5 moles and figure out how many grams it is. So we now have an answer. We know that there are 539.125 grams of iron 2 bromide in every 1 kilogram of water. But our chart gives solubility in grams per 100 grams of water. So there are a couple things you can do. One of the easiest is to think this. 1 kilogram of water is equal to 10 100-gram portions of water. So if we divide this number by 10, that will tell us how many grams are in each 100 grams. Okay? And then we can go to our table and we find that 100 grams of water can hold 144 grams of solute. So this is definitely unsaturated because we've got 53.9 grams per 100. Okay, so this could hold 144 grams per 100 grams of water, but we are only holding 53.9 grams, so it is unsaturated. That's your final answer. Okay, so number 3, what's the molarity? So here we have moved over to a molarity problem, just to keep you on your toes, of 2.75 liters of saturated iron 3 perchlorate solution at 0 degrees Celsius. So here we're going for big M equals moles of solute, that would be our iron 3 perchlorate, divided by liters of solution, right? There is a problem with solving this problem. What is it?
It's impossible to solve.
No, it's not impossible to solve, but you have to make an assumption. So let me draw something on here for you. So going to our solubility table, we find that every 100 grams of water can dissolve 289 grams of iron 3 perchlorate. That's like crazy solubility. Do we know the mass of the water that's in that 2.75 liters of solution? No, we don't. So you have to make some guesses and assumptions. And what I did, so if we, knowing that the density of water is 1, we'll make this 100 milliliters of water. Do we know how much of that 2.75 liters volume is comprised of water? No, we don't. Now, if we knew the density of iron 3 perchlorate, we could figure it out. So we would know how many grams of iron 3 perchlorate, we could figure out what volume it occupies, and we could work it out exactly. Since the person who wrote this question didn't give you that information, you can do a couple things, and what I did was actually an assumption. I assumed that probably about 2.7 liters of that solution was the water. I figured that the solute didn't take up more than about 50 milliliters of volume. So that gives me a mass of iron 3 perchlorate of about 7,803 grams in the whole kit and caboodle, the whole solution. No. So now that I've got this number, I've got grams of iron 3 perchlorate, I can figure out how many moles that is, do a straight molar conversion, and it works out to be 22.029, etc. moles of that stuff. So now we've got 22.02, etc. moles divided by 2.75 liters of solution. We get 8.01 molar solution. And if you assume that the whole volume was water, you'd get something between 8.01 and 8.16 molar solution. Okay, tomorrow, test, and I will put up another tutorial on molality.